we have a parabola, and we're supposed to find its equation. There's a number of different ways to do this, but a reasonable one is to remember that the equation of a parabola looks like this: y equals a times x minus p all squared plus q, where the point PQ is the vertex, and A, our leading coefficient, tells us about the size and shape of the parabola. If A is positive, it opens up. If A is negative, it opens down. And A can also give us the size of it and the essential shape using the method of differences. You recall the method of differences for A equals 1. For A equals 1, the method of differences says we start at the vertex and go over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5. So those points there, which I'm rapidly losing, right there, and there, and there, would determine the shape of it. And then it would be symmetric over there. Now clearly, the parabola that we have here is wider than that. So there are a couple of different ways of thinking of that. It could be thought of as a horizontal expansion, or if we start off like that, it could be a vertical compression, pushing all of these points down towards the x-axis. We can actually use the method of differences in this case to calculate the value of A. Here we go, over 1, up 1. Now clearly that's not working. So let's try, in this case, over 1, up 1/2. Well, it's not so good. Over 1, up 3 times. No, that's not going to work either. So perhaps that's not such a splendid way of doing it after all. Let's think. Over 1, up 1 would get us that point right there. Now, we've obviously had some sort of transformation where this point has been pushed that way. There's been a horizontal expansion. Instead of going over 1, up 1, we've gone over 2, up 1. And then let's assume over 2, up 1, 2, 3. So you see how that lands us right on the parabola. So instead of 1, we've gone over 1 times 2. So going over 1 again, we've gone over 1 times 2. So this value here is the horizontal expansion factor times 2. Well, what kind of transformation is that? That's x becomes kx, where k is less than 1 gives us our expansion. K in this case is actually the reciprocal of our expansion factor, as usual, which in this case will be 1/2. So we get x becoming 1/2 x. Well, why don't we start with our regular parabola, which is y equals x squared. The first transformation we need to do is this expansion. So y will become 1/2 of x. There I'm replacing x with 1/2 x all squared. I'm just going to do this. I get 1/4 of x squared. Well, right off the bat, it's looking like we've got 1/4 and 1/4, but let's keep going just to make sure. So far, what have we got? We've got a parabola with a vertex, right there. I've got a parabola with a vertex at the origin, which has been expanded horizontally by a factor of 2. So over 2, up 1, and over to up 1. That vertex we can see has gone down and across. It's gone down 1 and to the right 2. So there's two separate translations there. Our first one we could do down 1, which is y becomes y plus 1. Be careful, not y minus 1. It's y minus the k value, k in this case negative 1. And then we've got right 2, so x becomes x minus 2. So here's our function so far. We're going to replace y with y plus 1. And we're going to replace x with x minus 2. And you can see here this form of the parabola, the vertex form, starting to appear. I'm going to subtract 1 from both sides. Finally, I get y equals 1/4 times x minus 2 all squared plus 1. There you can see our vertex, which is at 2, 1, or PQ, a vertex at 2, 1. Let's get rid of all that. And there's our horizontal expansion factor. In this case, we're treating it as a horizontal expansion factor of 2. And that makes our correct answer right there.